This video demonstrates the Trace32 RISC-V core trace over USB using the Tessent Embedded Analytics technology. Lauterbach offers a debug and trace possibility for RISC-V targets over USB using a Trace32 front-end and a Trace32 back-end for Tessent Embedded Analytics. The communication over USB uses embedded analytics messages as protocol. The trace encoder monitors the program execution of the RISC-V core. This is done non-intrusively, meaning that the real-time performance of the program is not affected. This trace solution is compliant to Efficient Trace for RISC-V version 1. Please note that Trace32 also supports RISC-V off-chip tracing via ARM core site. The task of the trace communicator is to convert Tessent embedded analytic messages to a stream of bytes for the ARM core site trace bus. In this video, we're using a Trace32 PowerView for RISC-V version of April 2021. The RISC-V target is directly connected to the PC over USB. We are using a script to establish a debug connection over USB to the RISC-V target processor. The script sets USB 0 as debug port and configures the Tessent Embedded Analytics components. Since the Tessent Embedded Analytic technology was originally marketed under the name UltraSoC, all IP block names start with USOC. Now we need to set up the Ultra SoC trace. First, we need to select H-Analyzer, which is the trace method provided by Trace32 for supporting fast protocols as USB and Ethernet via a direct link from the host to the target. We then need to set the size of the H-Analyzer trace buffer on the host. Moreover, we need to connect the H-Analyzer to the UltraSoC trace using the command hanalyzer.traceconnect USOCRTE. Let's start the program execution and the trace recording for a couple of seconds. We see here the fill state of the reserved trace buffer. The trace results can be displayed by pushing the list button from the trace window or using the trace.list command. In this example, we're only tracing the program execution. If supported by the chip, Trace32 also supports data trace. In our example, we're using timestamps that are generated by the Tessent trace encoder. These timestamps are the only way to get time information for USB trace. If the trace is recorded with a Trace32 trace hardware, the timestamps are generated by the Trace32 trace module. Trace32 provides various further display options for the trace results. You can, for example, display the function runtime as chart or as statistics. This solution additionally supports trace filters that allow to reduce the generation of trace messages. For example, by limiting the generation of trace data for a specific function or operating system task. Please refer for more information about RISC-V core trace via USB to the Trace32 documentation and Trace32 website. Thank you for watching.